Lesson 7.2, proving triangles are right, acute, or obtuse. Proving a triangle is a right triangle is very simple. That's just applying the Pythagorean theorem and seeing if it works out. Is a squared plus b squared equal to c squared? If it is, you have a right triangle. Now for acute and obtuse, there's a little something new introduced here, but we're still building off of what we worked with previously. So here I have a squared plus b squared. If it's greater than c squared, then I have an acute triangle. If a squared plus b squared is less than c squared, I have an obtuse triangle. Okay, now a lot of students mix up their answers for these types of problems. Now how do you know which one's acute, which one's obtuse? All right, because a lot of students think less than means acute and greater than means obtuse, because less than is smaller and greater than is bigger. Okay, that's not the case here. You want to think the opposite. Okay, so greater than means you have acute, less than means you have obtuse. All right, let's do some examples. So for example 1, it's asking me to classify a triangle with the given side lengths as right, acute, or obtuse. Note, the side lengths are listed from smallest to largest, okay, because A and B will be your smaller values, and C will be the largest value. Okay, so I have 6 squared plus 8 squared is something to 10 squared. Okay, I'm using this dotted circle because I need to figure out what goes in there. Is it an equal sign? Is it a less than sign? Or is it a greater than sign? Then I'll be able to determine what type of triangle I'm working with. So I have 36 plus 64 is something to 100. So I have 100 is something to 100. Those would be equal. So I have a right triangle. All right, that's all there is to it. All right, now I have 6 squared plus 6 squared is something to 10 squared. I have 36 plus 36 is something to 100. So I have 72 is something to 100. What is that something? It's less than. So a squared plus b squared is less than c squared. That means I have an obtuse triangle. Done. For the next one, 7 squared plus 9 squared is something to 11 squared. So 49 plus 81 is something to 121. And then I have 130 is something to 121. 130 is greater than 121. So a squared plus b squared is greater than c squared, which makes this triangle acute. All right, let's do a couple more examples. Now I have the square root of 8 squared plus 4 squared is something to 6 squared. All right, now what's the square root of 8 times the square root of 8? That's square root of 64, which is 8. All right, so essentially the square undoes the square root. Then I have 4 squared, which is 16. And then I have 36. So if 24 is something to 36, that would be less than. All right, so a squared plus b squared is less than c squared, which makes this a triangle obtuse. For the next one, I have 2 square root of 3 squared plus the square root of 13 squared is something to 5 squared. All right, so I square 2, I get 4. I square the square root of 3, and I get 3. Then I have the square root of 13 squared, which is 13, and that's something to 25. So I have 12 plus 13 is something to 25. So I have 25 is something to 25. They're equal. So a squared plus b squared is equal to c squared, which makes this a right triangle. And let's do one more. So I have square root of 6 squared plus the square root of 8 squared is something to the square root of 10 squared. All right, so I have 6 plus 8 is something to 10. So I have 14 is something to 10. And that's greater than. So a squared plus b squared is greater than c squared, which makes this an acute triangle. Done. All right, example 2. The sides and classification of a triangle are given below. The length of the longest side is the integer given. What value or values of x make the triangle? Okay, so we're telling you the longest side is the integer given. That's your C. This is my C for all these problems. Okay. Now let's see, what values of x make the triangle? All right, they're telling me it's a right triangle, so I know x squared plus x squared is equal to 8 squared. So now I have 2x squared is equal to 64. Divide by 2. X squared is equal to 32. I'm going to take the square root of both sides. Let's simplify the square root of 32. 2 times 16, 2 times 8, 2 times 4, 2 times 2. Pair of 2's, another pair of 2's. Okay, so I pull out one pair of 2's, pull out 2 for the second pair, and I'm left with 1, 2 inside. So I end up with x is equal to 4 square root of 2. Done. Let's do part B. I have x squared plus x squared it's an acute triangle, so it's going to be greater than 6 squared. So I have 2x squared is greater than 36. Divide by 2. X squared is greater than 18. So I square root both sides. And I get x is greater than, let's see, breaking down 18, what do I get? 2 times 9 and 3 times 3. I have a pair of 3's, so it's going to be 3 square root of 2. Done. And for the last one, I have x squared plus 3x squared. And they say it's obtuse, so I have less than 10 squared. All right, do a little side note here. I see a lot of students write this out. All right, and what they forget to do is to square both parts. So make sure you put the whole thing in parentheses. Don't forget to square both parts. Okay. All right, so I have x squared. I have to square the second part first, so I end up with plus 9x squared is less than 100. And I end up with 10x squared is less than 100. I divide by 10. I get x squared is less than 10. Square root both sides, and I get x is less than the square root of 10. Done. Okay, that's it for the lesson. If you have any questions, please make sure to ask. Begin the assignment.